Welcome to the discussion. Today we're diving into a fascinating paper titled EUREKHA, Enhancing User Representation for Key Hackers' Identification in Underground Forums. It tackles the challenge of identifying key players in online criminal communities. This is a complex problem with significant implications for cybersecurity.
Absolutely. These underground forums are breeding grounds for cybercrime, and identifying the key instigators is crucial for effective threat mitigation.
Exactly. The sheer volume of data in these forums makes manual analysis nearly impossible. So, how does EUREKHA address this?
EUREKHA uses a multi-pronged approach. It starts by representing each user as a textual sequence, essentially a summary of their online activity.
A textual sequence? That sounds interesting. How does that help identify key hackers?
The sequence is then processed by a large language model acting as a feature extractor. This is where the magic happens. The LLM helps to understand the nuances of the language used by hackers.
I see. So the LLM is essentially making sense of the often cryptic and jargon-filled language found in these forums?
Precisely. But dealing with years of user activity is computationally expensive. That's where BERTopic comes in. It uses topic modeling to condense large posting histories into concise topics, making the data more manageable for the LLM.
BERTopic sounds like a powerful tool for data reduction. How does it work exactly?
BERTopic leverages BERT embeddings to capture contextual nuances in the text. It then uses dimensionality reduction and clustering techniques to group similar posts into topics, representing each user's activity with a set of relevant themes.
So the LLM receives these condensed topic representations. What happens next?
The LLM is fine-tuned for domain adaptation, essentially teaching it the specific language and patterns of the underground forum. This fine-tuning significantly improves the quality of the user embeddings it generates.
Right. And these embeddings are then used as input for another model?
Yes, a graph neural network, or GNN. The GNN leverages the structural relationships between users in the forum to further refine the representations and improve the accuracy of key hacker identification.
The GNN considers the network structure of the forum. How does that work?
The GNN models various types of interactions, such as quoted replies, threads, and even contract relationships between users. This contextual information is crucial for understanding the dynamics of the criminal network.
So the GNN combines the semantic information from the LLM with the social network structure of the forum?
Exactly. This combination allows the GNN to learn more nuanced representations of users, leading to a significant improvement in the accuracy of identifying key hackers.
And how does EUREKHA's performance compare to existing methods?
EUREKHA significantly outperforms state-of-the-art methods. In our experiments on the hack forums dataset, it achieved approximately a 6% increase in accuracy and a 10% increase in F1 score.
You mentioned the hack forums dataset. Tell us more about it and the pre-processing steps involved.
We use the Crime BB dataset, focusing on the hack forum section. It's a massive dataset with millions of posts and threads. Pre-processing was crucial. We cleaned the data, removing special characters and extra spaces, and replaced elements like URLs and code snippets with labels to improve the LLM's processing.
And how was the dataset annotated to identify key hackers?
We used a two-step process. First, an automated approach based on activity levels, reputation, and keywords identified potential candidates. Then, a manual review of their posts confirmed the classification.
The paper explores different ways of representing users as textual sequences. Can you elaborate on that?
We experimented with 4 different representations, varying the inclusion of full threads and replies versus their topic summaries generated by BERTopic. This allowed us to assess the impact of data reduction on model performance.
And which representation proved to be the most effective?
The representation that replaced both full threads and replies with their topic summaries, R4, performed best, demonstrating the effectiveness of BERTopic in data reduction without sacrificing crucial information.
What LLMs and GNNs were used in the experiments?
We used several popular LLMs, including BERT, Roberta, Albert, and XLNet, and combined them with different GNN architectures like GCN, RGCN, AT, and GTV2. This allowed us to evaluate the robustness of our approach across different models.
And what were the key findings from these experiments?
Fine-tuned LLMs consistently outperformed traditional GNN-based methods. The best results were obtained by combining strong LLMs like BERT and Roberta with advanced GNNs like JTV2 and RGCN.
Given the nature of the data, ethical considerations are paramount. How are these addressed?
Absolutely. We adhered to strict ethical guidelines, including a non-disclosure agreement with the dataset providers. Our analysis focused on collective behaviors, avoiding the identification of specific individuals.
What are some of the limitations of Eureka, and what are the avenues for future research?
Currently, Eureka is limited to a single forum. Future work will expand this to multiple forums and explore more sophisticated methods for ground truth annotation to reduce annotator bias. We also plan to investigate other LLMs and explore the use of content similarity analysis.
Can you share some insights from case studies of key hackers identified by Eureka?
We analyzed several key hackers, revealing interesting patterns. Many started by building reputation through free tutorials, later leveraging this to engage in illicit activities. Their posts often focused on specific tools and services, providing valuable insights for CTI.
The paper mentions hyperparameter tuning for the LLMs. Why was this important?
Hyperparameter tuning is crucial, especially when training on smaller datasets, to prevent overfitting and optimize model performance. We used a grid search to find the optimal settings for each LLM, significantly improving the results.
Let's revisit the comparison with baseline methods. What made Eureka stand out?
Eureka's superior performance stems from its ability to leverage both semantic information from LLMs and structural relationships from GNNs. This richer representation of users allows for more accurate identification of key hackers compared to methods relying solely on content or network structure.
So Eureka offers a promising approach to identifying key hackers in underground forums, leveraging the power of LLMs and GNNs to overcome the challenges of data volume and complexity.
Precisely. It provides a more accurate and efficient way to extract valuable CTI, aiding in proactive threat mitigation.
That was a great discussion. Thank you for sharing your expertise.